Now, we have a special session on energy from our partners Honda Accelerator Ventures, GTT, and Galp. We will kick off this session with a small intro from Luca Maurice, expert and track leader at Hello Tomorrow. Luca?
Good morning. Thank you for attending this pitch session about the energy track. So, energy is one of our most important track at Hello Tomorrow. It's the second one in terms of number of application, and it's also one of the most prolific. So the last two big winners of the Hello Tomorrow challenge were actually from the energy track. So we have observed quite a few trends recently. Most of the companies are working on energy storage, very big topic. We have observed the growth on clean fuels and hydrogen related companies. And most recently, we have seen a big growth and a big highlight of companies working on the supply chain of minerals, developing clean mining solution, and all these kind of topics. So it is really a pleasure for us to welcome this. We have selected 7 very amazing companies, thanks to the help of our sponsors. And I'll be happy to let the mic so we can present the sponsors. And sit back, relax, and have fun.
Very quickly.
Thank you very much, Carol. We go to Charlie McGillum now. He's the CEO of ElectraLith from Australia, unlocking a green future with the cleanest, most versatile, and most cost-efficient method of extracting and refining lithium. Charlie?
Okay, thank you very much. I appreciate being here. I'm talking today about lithium, which is something I really like talking about. It's something we can all relate to. It's in our watches, it's in our laptops, it's in our phones, and increasingly, it's in our cars. And we think of lithium as one of the solutions, one of many solutions to global climate change. But we don't often talk about is the environmental cost, the actual impact of extracting and refining lithium. It takes about 770,000 liters of water and nearly 2.5 tons of carbon dioxide are emitted over an 18 to 24 month period where almost 60% of the lithium is lost to produce one Model S Tesla, the battery just for one Model S Tesla. Now this is terrible for the environment, it's obviously terrible for the economics of the car, but it's also terrible for the environment, the indigenous communities that are processing this technology. And here you can see some of the community members shoveling this toxin. You can also see the water that's in the background. Roughly 60% of the water in the Andes is used for lithium extraction. ElectraLith is solving this problem. We're developing the next generation of direct lithium extraction technology. Our technology uses no water, no chemicals, and can operate entirely on renewable energy. And we can extract and refine lithium directly at the source. So we remove the dependence on China and others. And we do that with a proprietary membrane. The proprietary membrane uses 3 volts and essentially uses electrodialysis, which is from high school chemistry, for those who remember, to remove that lithium. And the residual lithium, brine, I should say, goes back into the aquifer. By removing water and chemicals from the equation, we've got the lowest environmental footprint. But also by removing those externalities, we also operate at the lowest end of the cost curve. We'd like to think of it as the intersection of cost and environment. And it works. This slide is my favorite slide because sometimes I worry it doesn't come up. It does work, and we've proven it throughout the world. In fact, we've got 18 chemical engineers based in Melbourne, and we've proven it on brines from Latin America, from North America, from Europe, and elsewhere. And through that process, we've also gained an incredible amount of customers and traction. You may have seen us in the Financial Times, recently in the Wall Street Journal. And those tailwinds have helped us close our Series A. We were fortunate enough to close at the very end of December, raising about 20 million US. And more important than the money is the quality of our investors, Rio Tinto, Chevron, Marathon, and In-Q-Tel. And we're using those monies to scale the process, which we intend to pilot in Argentina in the next 12 to 24 months. So very much looking forward to your questions, and thank you very much for the opportunity to be here.
Great job, Charlie.
Congratulations, great pitch. It's almost too good to be true, what the story you are telling. So about that pilot in Argentina, it's going to be it's it's scaling. Are you doing a factory or are you just doing a lab?
It will be a modestly scaled pilot, so it'll be almost commercial size. It'll be used by Rio Tinto, and it'll be the size that they require for them to build a much larger plant. And funny that you mentioned it's too good to be true. In the Wall Street Journal and others, I always say to our investors and to the media and to our customers, there is a catch, and that is that we need a year to develop the technology. When it works, it'll be the best, but we do need that time. So we do like to say it is too good to be true, but it is on the process of being true.
Thank you. Thank you very much for the pitch. My question is, how deep are you going in the value chain? Do you basically extract and then sell the commodity, or how's the model?
No, thank you. Our goal now is just to make the technology. We prefer not, particularly as a venture capital business, we don't want commodity risk. We don't want any of those externalities. Our customers, Rio Tinto, Chevron, Exxon, they're very much focused on that. They look at us and they think we need that technology and we need it to work.
Thank you.
Oriane?
Thank you for the pitch. Could you tell us a little bit more about the technology itself and the IP around it, and also how you regenerate the membrane?
So the membrane is a proprietary patented membrane. It uses a combination of ceramic and polymer compositions and a number of elements in a formulation that makes the membrane work. It's obviously very proprietary to our business. We currently have it at a 64 square centimeter size. And we need to grow it to about 1,000 square centimeters. And that's what we'll be doing over the next year or so. It is that technology that underpins what we're doing. The rest of our technology, or the rest of the process, uses off-the-shelf electrodialysis equipment, and that's really important because it focuses the actual technical risk squarely on that membrane.
Manuel? Or?
And thank you for your pitch. If I understood well, you need to be close to the brain aquifer. Do you have any? What is the availability of the brain aquifer in the world?
The brines are actually, lithium is one of the most ubiquitous elements on the planet. So we actually are doing work, we just started a relationship with Aramet. There's a brine in Alsace that we're beginning to process or do work on. Most of the brines are in Latin America, the Paradox Basin in southern US, that's where ExxonMobil is. So it's well and truly throughout the planet. Our technology is scalable and modular, so we can take the technology to the customer and produce lithium on site.
Great. Thank you, Charlie.